NASA's James Webb Space Telescope was built to look deeper into the cosmos than any previous space telescope. Its mission was simple in concept but enormous in ambition. Look back toward the earliest chapters of cosmic history and observe galaxies, stars, and planetary systems that formed billions of years ago. But Webb has done more than produce spectacular images. It has revealed a universe that is far more complicated than scientists once imagined. One of the biggest surprises came from the discovery of extremely distant galaxies that existed only a few 100 million years after the Big Bang. Some of these galaxies appear brighter, more massive, or more chemically developed than early models predicted. That does not mean the Big Bang has been disproven. It means scientists have had to examine their assumptions about how quickly the first galaxies formed, how efficiently stars were born, and how early massive structures could develop. And that is where the real mystery begins. When astronomers look deeper into space, they are also looking further back in time. The light reaching Webb today may have started its journey billions of years ago. Every photon carries information about an ancient universe. Webb's infrared instruments can detect extremely faint objects that were previously difficult or impossible to observe. Behind apparently empty regions of sky, astronomers have found enormous numbers of distant galaxies. The deeper Webb looks, the more complex the cosmic landscape becomes. Galaxies are connected through enormous structures of gas and dark matter, forming what scientists call the cosmic web. Between these structures are vast regions containing relatively few galaxies. And yet even the darkest regions can contain faint objects that reveal something about the universe's hidden history. Perhaps the most important lesson is that the early universe was not simply a quiet place where structures slowly appeared. It may have been energetic, chaotic, and remarkably efficient at producing stars and galaxies. Scientists are investigating how the first stars formed, how early black holes grew, and how galaxies assembled their mass so quickly. Some early galaxies also contain elements that suggest previous generations of stars had already lived and died. That raises another question. How could stars have formed, evolved, and enriched their surroundings so rapidly when the universe itself was still so young? The answer may involve processes that are more efficient than older models assumed. Webb is also transforming the study of black holes. Astronomers have found evidence of massive black holes existing surprisingly early in cosmic history, creating new questions about how these objects could grow so quickly. None of this requires physics to collapse. Instead, it shows science working exactly as it should. When observations disagree with predictions, researchers investigate the difference. They improve their models. They test alternative explanations. And they collect more evidence. Webb has not discovered a doorway to another universe or confirmed intelligent alien civilizations. Its genuine discoveries are already extraordinary enough. It has shown us that the universe became structured remarkably quickly, that ancient galaxies can be surprisingly complex, and that the story of cosmic evolution is still incomplete. And perhaps the biggest revelation is still ahead. Because Webb is not only studying ancient galaxies. It is also examining planets orbiting other stars. And if astronomers eventually find convincing evidence of biological activity on another world, the consequences would be enormous. For now, Earth remains the only world known to support life. But Webb is giving humanity a better opportunity than ever to investigate whether that uniqueness is real. And the deeper we look, the harder it becomes to believe that we have already seen the full story of the cosmos. The James Webb Space Telescope has changed something even more important than our images of space. It has changed the questions scientists are asking. For decades, cosmologists developed models describing how the universe evolved from its earliest moments into the enormous cosmic structure we see today. Webb is now testing those models with unprecedented observations. Some galaxies appear earlier than expected. Some black holes seem to have grown remarkably quickly. Some planetary systems look dramatically different from our own. And every unexpected observation forces researchers to investigate another piece of the puzzle. One possibility being explored is that early galaxies were simply more efficient than scientists once believed. Perhaps stars formed faster. Perhaps young galaxies produced enormous amounts of radiation. Perhaps black holes grew through processes that allowed them to reach massive sizes sooner. Or perhaps several of these effects worked together. These questions matter because the first galaxies eventually transformed their surroundings. Their stars produced light and heavy elements. Their radiation affected surrounding gas. Their black holes influenced their host galaxies. Over hundreds of millions of years, these processes helped transform a young universe into the structured cosmos we see today. Webb is essentially allowing scientists to watch pieces of that transformation. And its mission extends far beyond the early universe. The telescope can study the atmospheres of exoplanets by analyzing the tiny changes in starlight that occur when a planet passes in front of its star. From that light, researchers can search for molecules such as water vapor, carbon dioxide, methane, and other atmospheric compounds. Finding one molecule would not automatically prove life exists. But a combination of atmospheric gases that cannot easily be explained by known geological or chemical processes could become an important clue. That is why exoplanet research is so exciting. Humanity is beginning to investigate worlds that may be completely unlike Earth. Some orbit red dwarf stars. Others are gas giants located extremely close to their stars. Some may be rocky planets with atmospheres that scientists are only beginning to understand. The universe is showing us an enormous diversity of planetary environments. And that diversity creates another profound question. If planets are common, and the ingredients for life can exist in many places, how common is life itself? We still do not know. Webb has not confirmed extraterrestrial life. But it has dramatically expanded our ability to search for the conditions that could support it. At the same time, Webb's discoveries remind us of something important about science. A telescope does not provide every answer. Sometimes its greatest contribution is revealing how much remains unknown. The universe may be older, more complicated, and more dynamic than our simplified explanations suggest. That does not make science weaker. It makes the search more exciting. Future observatories will build on Webb's discoveries, studying even earlier galaxies, more distant planets, and the mysterious forces shaping cosmic evolution. One day, another telescope may detect the first stars. Another may directly characterize an Earth-like planet around another star. And perhaps one day, humanity will detect convincing evidence that life exists somewhere beyond Earth. Until then, the real story is already astonishing. The James Webb Space Telescope has not rewritten the laws of reality. It has expanded the boundaries of what humanity can observe. And every time Webb looks deeper into the darkness, it reminds us that the universe is not running out of mysteries. We are simply getting better at finding them.